Hey guys, this is Coach Lowe, and we are going to talk a little contextual geometry. This is Chapter 2, Section 3, Congruent Segments. All right, so let's get going. So you need to write these terms in your definition section. Actually, you have a sheet that has definitions and you have one with theorems, so you need to add these on there. Congruent segments, two segments are congruent if and only if they have the same length. Remember, if and only if means it works both ways. So two segments are congruent if they have the same length, and if two segments have the same length, then they are congruent. Midpoint. A point M is a midpoint of segment ST if and only if M is between S and T and segment SM is equal to segment MT. Again, this works the other way too. If M is between S and T and those segments SM are equal, so SM and MT are equal to each other, then M has to be the midpoint. All right, so remember, anytime you need to pause this video to write things down, please do so. So the first theorem, congruence of segments is reflexive. So if I have two segments that are congruent to each other, reflexive property, or the theorem 2:1 says I can flip those letters around. It doesn't matter if I start from A and go to B or from B to A, they are the same measure. So they're congruent, which means they have the same measure. So congruent segments is symmetric. So the congruence of segments is symmetric. That means if segment AB is congruent to segment CD, then CD is congruent to AB. So doesn't matter which way I look at that, the congruency holds. So they're equal in measure. All right, congruence of segments is transitive. So if I have segment AB that's equal in measure or congruent to segment CD, and then I also know that segment CD is congruent, see if I can get that written down there, to EF, then I also know that AB is congruent to EF. So let's talk about that real quick. If my first segment is the same measure as the second, and the second is the same measure as the third, then this first one would be the same measure. So let's say the first one is 12 meters long, and this one would be 12 meters long. Well, if CD is 12 meters long and CD is the same as EF, then I know that's 12. So it's saying from there that segment AB and EF are also equal in measure or congruent. All right, hope that makes sense. Make sure you ask me about that tomorrow if it doesn't. All right, now let's start on our exercises. So example number 1 says, draw a number line, make B the midpoint of RS. So draw a number line. We did some of this today. Make B the midpoint of segment, put a little segment sign above RS on your paper, of segment RS. So here's RS, and B is the midpoint. If you had a compass at home, then you could construct that midpoint, couldn't you? Because we talked about how to bisect a segment this week. So that's awesome. All right, now you get to try. Draw a number line and make T the midpoint of AC. Make T the midpoint of AC. Draw a number line, make T the midpoint of AC. All right, so make T the midpoint of AC. Let's go ahead and draw that. I'm going to put numbers on it this time. So let's think about that. Let's go with -1, 0, 1, 2, and 3. So let's say that A is at -1 and C is at 3. Then where would my midpoint be? Well, the midpoint is going to be halfway between the two. So the distance from -1 to 3 is 4 units. I need to go halfway, so I need to go 2 units to get to the midpoint. So there's my midpoint, and it said name the midpoint T. All right, so there's example number 1. All right, let's go on to example number 2. Label a number line so that AB is longer than CD. So segment AB, put segment signs above A and B, which means you're just going to draw a line above them on your notes. All right, so here's my number line. And this time I'm going to start at -3, -2, -1, 0, 1, 2, 3, and 4. All right, so let's draw AB, and it needs to be longer than CD. So here's A, and let's stop that at 0. So there's AB. It is how many units long? 3. Absolute value to find the length, -3 minus 0, looking at the distance between the start and the stop. So the difference to find the distance. And that would be the absolute value of -3, which is 3. All right. And then we're supposed to make CD shorter. So AB has to be longer than CD. So let's start here at 1 and let's stop at 2.5. So there's CD. It is 1.5 units long. 2.5 or 2.5 minus 1, absolute value of that is 1.5 or just 1.5 or 1.5. All right, now you try it. Label a number line so that RS is shorter than TU. Segment RS, so segment RS is shorter than segment TU. All right, so you try that one. Pause the video and try it on your paper. All right, so different ways you could have done this problem. You just need to make sure that RS is shorter than TU. So this is not the only answer, but all right, so I am counting by ones. Above I was counting by halves. I'm counting by ones even though I have only labeled every 5. So RS is going to be shorter, so I'm going to start at -4 and I'm going to stop at -3. So RS is 1 unit long, and TU needs to be longer, so I'm going to start at -1 and go all the way to 3, which would make TU 4 units long. -1 minus 3 is a -4. Absolute value of -4 is 4. So TU is 4 units long, RS is 1 unit long. All right, label a number line. So QW is congruent to VQ. QW is congruent or equal in measure to VQ. All right, so this is example 3. QW is congruent to VQ. You need to put segment symbols above that and then the congruent sign in the middle on your paper, so they are congruent to each other. All right, so let's get a number line going. So what do I know about Q? Where should Q go? You're exactly right. Q should go right in the middle. All right, so I have W and Q and V. So WQ is congruent to QV. All right, so we can say that this is -10, 0, and 10 would be perfect numbers to use for this. And then I'll go ahead and draw my segment here. So 10 units and 10 units, those segments are congruent to each other. All right, you go ahead and try labeling a number line. So SV is congruent to TS. All right, now that we're back, you should have drawn a number line kind of similar to what I did, and you could put any numbers on there, but those have to be equal to each other, and S will be the midpoint. S is the midpoint, just like in our case, Q was the midpoint, and that midpoint doesn't have to land on 0. It can land anywhere, wherever you've decided to place it. All right, last one, example number 4. If segment AX is half the length of AY, segment AX is half the length of AY, then A is the midpoint of AY. All right, so let's think about this. If AX is half the length of AY, all right, so AX is half the length of AY, then A is the midpoint of AY. Is that true? AX is half the length of AY. That makes X the midpoint, doesn't it? All right, so that would be false. All right, your example. true or false. A line has only one bisector. A line has only one bisector. All right, so hopefully you have checked that out. That is false. A line does not have only one bisector. It can actually have many bisectors. And usually we don't bisect lines anyway. We bisect segments. So we will look at that in class tomorrow. So good job today, guys, and I will talk to you soon. This is Coach Lowe, and I'm out.